Hello. Okay, so it looks like we have a lot of people joined, and we're really excited to start. So my name is Anna Chen-Yun Tai. I'm a CEO and co-founder of Episcore. I'm here today with Trevor Ragnaud. He's the Director of Construction Technologies at Episcore. Hey, Trevor.
Hello, good to be here today.
Yeah. So the investor webinar, it's part of our monthly webinars, but honestly, we have not hosted the webinar since for like the last 2 months. We were very, very busy. So we're really excited about this webinar. And I know that there are a lot of people who already invested, and there are also a lot of people who just discovered our company and really eager to know more about the technology itself, about the company and our plans. So our presentation today will still consist on the standard information, like the basics about the technology, the company, and we also include the company updates and what's going on right now. Then we're going to have about 15 minutes of Q&A. Sometimes we go longer, but let's see how it goes. And so I'm ready to start and really excited about seeing you all today. And first of all, before I start, this investor webinar is more informal format of the information we provide. Please do not use it as a financial advice to make a decision to invest in our company. You have to read all of the offering memorandum on Start Engine before making a decision to invest. It's really highly regulated, and all of the information we share today, it's some of it based on our judgments and our estimations, or like market available estimations. So please remember this while we are telling you about our company and technology. Okay, so we are Episcore, and we build 3D printing robots for faster and lower cost construction. And our company name came actually from bees. Apis, it means bees in Latin. And bees are actually the first ones who ever used 3D printing to build their homes. As you know, they somehow extrude wax and they 3D print their honeycombs, basically. So that was the inspiration for our company name. And hear more about our company. We started the Episcore together with Nick Chen-Yun Tai. He's the inventor of the technology, and originally the idea of the Frank the design of the Frank came to him. Before Episcore, we executed a very big construction-related project on Olympic Games. And we basically had to design, manufacture, and deploy 5,000 navigation signages all across the coastal area. And we saw how outdated construction industry was back then. And we decided that it has to be a better solution for construction. And this is how we came up with the Episcore, and specifically Nick came up with the revolutionary design of the 3D printer, which we call today Frank. We also have Trevor Ragnaud, our Director of Construction Technologies, and I'll let you, Trevor, to introduce yourself.
Hi, yeah, thanks, Anna. Yeah, I've spent a lot of time in construction, built mostly commercial, but had a long history with everything from self-storage, multi-story and multi-family buildings, did some data center work, really got to see what it's like to be in the traditional construction industry. It's something that not a lot of other companies in our space have. It seems like everybody's very focused on technology. So really being able to design technology for the construction field has been something that's really helped us with deployment acceptance. I'll be here to kind of explain a little bit more about the construction processes and how the machine works and what we do out in the field. Thanks, Anna.
Perfect. Thank you. Yeah, and we also expanded our team significantly this year, and it's a very exciting time for us this year. So now more about briefly about the problem. I believe you're all familiar with that modern construction technology. It takes a lot of time, it's inconsistent quality, and it heavily rely on the skilled labor. And home builders, they really struggle to consistently have available trades on site. They may have like 10 people working today, but nobody will show up tomorrow or even pick up the phone. So they constantly battle in this consistent construction flow and process flow. And we believe that it has to be a better solution. So this is why we created Frank. Frank is the construction 3D printer, which is highly mobile, very transportable, and just one person needed to operate Frank and Gary. And Gary is our proprietary mixer. So we name all of the robots we create. We have Frank, Gary, and Mary. Mary, it's a big bulk truck that delivers the material to the construction site. Using our tech, we 3D printed the Guinness World Record building. It's a 2-story large administrative building, and nobody still can beat this Guinness World Records. Here you also can see how easy Frank and Gary can be deployed and transported using regular pickup truck and trailer. And just again, one person needed to do that just using the joystick and iPad. This is something that fundamentally differentiates us from all other solutions on the market. And here you see how modular the 3D printer. Basically, there is no such a thing or problem. This is a big building for Frank. It's like a 1,000 square feet building or 10,000 square feet building. Frank can 3D print any of that. Again, due to the mobility and how agile the system that we created. Using our solution, home builders basically significantly reduce need for labor. It's one person to operate Frank and Gary instead of like a 10-person crew on site. More importantly, Frank is available every day, 24/7, and Frank does not cancel the job. The houses can be way more affordable to build. We estimate that it can be up to 20% cost savings for finished house using our system. And it can be faster, like we estimated it's going to be 2 months to complete the house instead of 7 months that taken right now using the traditional construction methods. And it's consistent quality, zero waste, and less logistics. And all of these numbers are really applicable for our solution specifically. Because again, how the easy to use the printer that we developed, and Trevor going to tell more about this, of all of the atoms of all of the costs of operate and use our system. And here you see the Guinness World Record that we 3D printed, another building that we 3D printed in Texas. And also throughout our journey, we built and developed almost four iterations of Frank. The old Frank was really big and bulky, and it was not that mobile, but still it's 3D printed the Guinness World Record. And here you see on the right the most advanced and the recent version of Frank that right now is actually on the market for the home builders. Our business model is that we position ourselves as a technology providers for home builders. We are in B2B business model. And in a nutshell, we basically the razors and blades business model on steroids. Well, what does it mean? We provide robots for renting, and then we sell our 3D print material for users of our 3D printers. And robots are razors, and 3D print material is blades. And just estimating the market for this specific business model is going to be more than $60 billion market opportunity for our specific technology and business model. How we calculated it, we basically saw how many residential houses built annually in the United States. Let's assume all of them would be 3D printed. That would be the market opportunity for us. And then we saw how many active home builders and construction businesses today in the United States. And we multiplied it by annual rental. That would be the market opportunity for us just for the robot rental. And hear more about the 3D print material, the goal for this business model, how we going to achieve the specific milestones by 2027. Our goal is to have 400 printers in operation, and we know the conservative productivity of each printer. And if all of these printers work even 8 hours per day, they will need 3 billion pounds of 3D print material annually. right? And that actually equals to 20,000 single family houses, which is just fraction of the current market in the United States. It's 1.5% of the market of the single family construction market today. And to achieve that, we will need to have 200 home builders actively using our printers, considering each of them using 2 printers. However, we do already have potential customers who wants to purchase 10 printers, right? So even to achieve these numbers, we may need even less number of home builders actively using our system. And 3D print material, I know that there are a lot of people who want to know about what is 3D print material, how different it is. So it's basically concrete-like material, but it's not the concrete that you see pouring on the construction sites, on the construction slabs, or like the roads. That material is basically a puddle. It's very liquid, and it cannot be extruded. Our 3D print material is basically a proprietary blend: sand, cement, and secret sauce, as we call it. Secret sauce is the combination of components that makes material extrudable, printable, and also with all of the physical properties that requires by building codes. This secret sauce consists on the existing components that already used in concrete and construction. The magic behind this is basically what exact components you use and what the ratio between them. Because sometimes if you add some of the components, let's say 1%, and then you added 1% more, the entire material going to look completely different, and you will not be able to print. So this is quite significant material science behind that, and we're really proud that we spend a lot of time to figure out the best formula for this, and we accumulated significant experience in that. And in the future, we even plan to transition to cement-free materials. We already tested it. So that will allow us to reduce the carbon emissions and CO2 emissions during the construction process. So I also know that some of you asked like how the user is going to make money and why it makes sense to introduce the 3D printed of the walls. Basically, the construction of the walls can contribute to almost 40% of the overall cost of the house. That includes all of the labor, all of the materials, concrete blocks, or the other materials just to build the wall. Then it's the reinforcement, insulation, all of the stucco, all of the paint, everything just to get the wall that people want to live in, right? The walls where the people okay to live in, not just the ugly concrete wall. So using our technology, we can reduce the cost just to build the walls up to 46-ish%. And that will contribute to the overall cost savings of 20%, up to 20%. I'm saying up to 20 and like up to something, because it really depends on the design, on the location, on what systems you want to use, what the finishes you want to use. This is really generic and average, but it provides the very big picture how the economics of walls really play a role in the overall cost to build a house. And again, these numbers are only applicable to us, to our technology, because first of all, this is on the left, the quality of walls that we print. And you can see how straight it is. We don't have these sausages and all of the grooves between sausages. On the right, for example, you see the walls have other technologies mostly print. And it's not even like the most ugly walls that exist today in the industry. So when you have all of these grooves and all of these big layers, first of all, you need to spend way more materials and labor just to smooth out the walls, because you need to fill all of the grooves with the stucco. So you can use even 3 times more stucco than for the needed for our wall, for example. And then you spend way more 3D print material. You can see how big layers are on the right pictures. Our material, our layer is very compact, because we're really fighting a lot of economic, a lot of numbers and money, how to save them on the 3D printed wall. The goal is not just to pour a lot of materials, but how to actually use less material, but still have the structurally safe and sound wall. So it's even like a lot of engineering behind the actual wall and what the material and how big the layer should be. And in addition to that, our system itself, Frank and Gehry, way easier to operate and deploy. It's agile and it's not that expensive just to, to transport and deploy the system. On the left, you see the building in Dubai that we 3D printed. And in this yellow circle, it's our printer. And you can see how small it is compared to the envelope of the building. And to transport Frank, you only need this car. It's basically standard pickup truck and the trailer, of course. Most common printers like this one, big gantry printers, and I see the question in the Q&A about Icon. They basically use the same system. It's gantry style printer, and most of the companies use the same style of equipment. They actually didn't invent it. They just made the plastic 3D printers that you use on desktop and just make them bigger 1,000 times because they thought that like this is what's needed to 3D print buildings. That actually works, but economics behind this is completely like it's so expensive because you need to have about 3 18 wheelers like this just to deliver parts of all of this gantry printer, and then you need about like 10 days, sometimes even 14 days, and about 10 people just to assemble this together and get the system up and running. But I will leave it to Trevor to tell more about this, but I just wanted to demonstrate you how smaller our system compared to other systems. And again, for our Frank, we could even 3D print a building 10 times bigger like this because we just move the printer and keep printing the walls. And I'm sorry for the sound. I'm going to show you the Trevor, is it very loud?
I don't hear very much on my end. That's fine. I think we can get the idea here. Yeah, on mine, the video looks a little stop and start, but essentially this is just a consistent timeline showing what it looks like to get out of the car, unload the mixer, and unload the printer.
Oh, okay. So, So basically, because I forgot to turn off the sound, I just don't want you to be overwhelmed with the video. Basically, this video shows how Frank and Gehry transported by pickup truck and trailer and can be easily uploaded by one person and using the iPad that you see right now on the screen. So we just going to keep watching this video, but it really provides you the idea how agile and how compact and how easy to do everything with the Frank and Gehry. And you can see that they're all mobile. Yeah, so that basically everything that operator or home builder will need to have to use our system. And these two small and compact little tanks, they can 3D print walls of any side of the building. I think that's really fascinating, and it's really tool, right, that you can easily use and build buildings. It's not like this heavy gantry, something that makes the cost to build house 10 times more expensive. It does not make sense at all. So you can see how different we are. And hear more about our company updates. So first of all, about sales and product presentation. So as you may know, we started our commercial launch in late January this year. We basically started offering Franks and Gehry for sale to home builders in the United States and worldwide. The interest was really and demand was very overwhelming. We already made 2 sales, and we sell Frank at $650,000. And we also collected 26, and today it's even more, paid reservations for Frank and Gehry. And each reservation costs $3,000. So it's not just empty promises. People actually want to purchase the Frank and Gehry at this price with this lead time. And once we sell all of the sprinters and get them in operation, that will bring us potential revenue of $41 million on the material, and that's going to be the recurrent revenue. So that basically the numbers that can demonstrate to you what is the revenue opportunity that we're working on right now to lock, and we would like to see this all of the next year. And to complete our reservations that we have, we're going to do a product presentation. It's basically a live demo, because all of these people, they already made the research in the industry. They already love our system. They already want to proceed further. They just saying like, I want to see the machine in operation, for 5 minutes, and I'm going to check my box and I'm going to sign the sale. So this is why it's really exciting for us, the product presentation. We already have about 45 people registered, and they come in. And what is more really exciting is that one of the national home builder is going to come and see the machine in operation. And although we cannot really share a lot about the name and what's going to be, but once we have this discussion, which is going very actively, once we have something like a more solid commitment or like a plans that we can announce, we're really going to do this. But again, we have a lot of really promising and high level guests coming to the product presentation. And this is why right now, all of our team basically preparing for the product presentation is really going to be a very big milestone for us. So it's going to be on August 17th through August 31st. And again, slots are already come and booked. So we're going to share more information about that commercial traction, I think maybe in September, late September, basically after August. And another company update, it's the product improvement. Basically, we recently shared about the Gehry 2.0. And it's really a piece of art, I would say, and really sophisticatedly engineered equipment. And it's not just something that we want to do fancy machines or something like this. We used Gehry 1.0 on previous projects, and it was not perfect, and we didn't want to release it, and we didn't want anyone to experience what we experienced with Gehry 1.0. However, it was already well advanced and way better than the plastering machines we used before. So we spent time to significantly improve the Gehry, and right now it's very easy to maintain, very, very easy to use. Mixing process is way better, and cleaning process is way better. So we're going to share this all in the product presentation. And in September, we're probably going to release online version of the product presentation so more people can see it. And our production facility, we significantly expanded our pilot manufacturing facility here in Melbourne, Florida. We got a couple of the brand new CNC machines, and a lot of tools. We improved our space because we're preparing to manufacture more printers. So all of the investments that we raised so far was really instrumental to get it done. And we're really excited about the expanding our manufacturing capabilities. And what's going to happen next? We right now working on to build our model house. And then after model house, we're going to build more pilot projects with the home builders, basically our early adopters in Texas, in Florida, in Louisiana, California, Montana, and South Dakota. But model home is the first before we go into do anything else. Model home is like 5 minutes from our headquarters, and we going to test a lot of different techniques and all of the improvements there. And then we will be ready to go and print houses like without any stops, because this is our goal. With the model home, we almost done with the building permit. And some of the hurdles with the building permit was just probably really hard to believe, but it was septic permit. And Trevor will tell more about that. So it's even not something about the 3D printed walls or technology. It was really septic permits. And we spent, I don't know, maybe like 3 weeks there to figure out how to make it happen. But again, like we solved it, and it's like a couple of lost papers that we're waiting for. And hopefully we're gonna get our building permit soon. And now about the investment opportunities. I know a lot of people really interested about that. So our progress on investment so far, maybe most of you know that we raised $1,200,000 on Regulation A+ previously in 2022. That was before Reg A+. That round is closed. Thank you everyone who invested. Those money was really instrumental for us to achieve everything that we have today. And right now we have Regulation CF on Start Engine. Thank you all who invested in us and believed in what we're doing in our vision. That really means a lot for us. If you invest in us, we have a bunch of really cool perks, free online courses, live Q&A with me and Trevor. It's kind of like different than the webinars. We also add you to a wait list for home at no cost. It actually costs $200, but investors on the specific tier of the investment going to be added for free. And for this very high tier, specific number of investment, you will be invited to the live printing of a house. So that's basically it, what I wanted to share. Company updates about us, and now I'm going to pass it to Trevor, and he's going to talk more about the technology, the competition, everything that I maybe like slightly touched, but Trevor going to tell it in a more compelling way.
Well, I'm not sure about more compelling, but I'll certainly make sure we can cover some of our bases on those really popular questions people have. Thanks so much for the introduction there, Anna. Right off the bat, at least a few things, if you've been following us for a while, you might be familiar with some of our projects, things like one of the world's most recognized 3D printed homes. We've really been involved with NASA, one reason why we're here in the Space Coast. We've won multiple first place awards at the NASA Mars Habitat Challenges. Anna touched on the Guinness World Record that we'd set back in 2019. But things like having the first commercially permitted 3D printing building in America, those are things that really show that we're able to get traction and get permitted and get deployed pretty easily. Of course, we have some patents you can learn more about on our website as well, or check it out on USPTO. We'll talk about that in a bit, but just to make sure we have people in this meeting that have different levels of knowledge about construction, how it's done now and how we do it. So just to kind of make sure we're on equal footing here, looking at traditional construction, something I definitely experienced out in the field a lot was human error. Human error is one of those things that is pretty inevitable, and it's pretty expensive. When you build something and have to demolish it, you've wasted your time, you've wasted your labor. And if you don't demolish it and you continue working around, let's say, some walls that aren't perfectly straight or perfectly plumb, it really affects every one of those other contractors down the line. Your flooring guy is going to have to make adjustments. When you're doing baseboards and crown molding and putting in kitchen cabinets and drywall and everything else, every other contractor is making adjustments. And that requires an extra level of skill. It requires more money. So using a robot to build that primary structure right off the bat, it really ensures that you are starting with a high quality product that is built with robotic precision. When it comes to what's actually built, once the robot leaves the site, most homes in the US are built out of wood. This is flammable, absorbent termite food, essentially. It's something that's not really built to last a lifetime. We here in Florida are really big fans of concrete because of the extreme weather events that we experience, and because of some of the savings in terms of maintenance and HVAC. So building out of something, we build out of what's essentially like a high strength mortar or concrete. It's about 33% stronger than concrete block homes that are already out there on the market. So something that is really great for those home buyers. As a builder, delays are one of those things that everybody's facing, especially in a post-COVID world. Right now, median delays out in construction site are up to and around 200 days. So not only are you able to build faster with a printer, but even more importantly, you're able to know before you ever step foot on the construction side, a site, how long it's going to take to build that home down to the second. We know exactly what these printers are going to be doing while they're out there. So this makes it really easy to schedule those subcontractors and keep construction moving, and ultimately just reduce risk to your timeline and your budget. Now, there's definitely a lot of environmental concerns around the construction industry. Part of that's because construction and demolition waste is by far the largest contributor to landfills. So using a technology that's not reductive, you aren't cutting 2x4s and sheets of plywood. You're adding only the material that you need. So it's zero waste. It's all electric, and the material that we're using, including the steel reinforcement, that's fully recyclable material. So definitely something that can help create a greener home. And one of my favorite things here on the design side is this architectural freedom. You see a lot of homes out there with straight lines and hard corners, and that's not because there's a lot of straight lines and hard corners in nature, or because we just like straight lines and hard corners more. It's mainly because that's how the materials come. Your straight, 2x4s, your straight pieces of lumber, your square blocks. We can print a curved wall that's typically only seen in luxury construction. We can print that at a really affordable price, just as affordable or even more affordable than us printing a hard corner, which we can do. We can cut the corner and print something that's really not only aesthetically appealing, but also something that functionally can work better with the designs and environment that you choose. So this is going to be recorded, and that recording is going to be available to you. So don't worry about all the information that you see on screen right now. These are just some of the specifications of the printer, Frank. And here's a little bit more on Gary. Gary is this mixing machine that we use, and most of the industry out there, they're using plastering machines. These are been around in construction for a while. It's something that they are a massive headache to use. Really, creating our own mixing machine was a real way to avoid having to use these. They're expensive. They are extremely difficult to clean. They need to be cleaned very often. We often have to use things like sludge hammers to be able to, break off cavity pumps and actually get them open and clean them. So moving over to a technology that now, the Gary 2.0, it's kind of the second generation, is really helped us because the mixer is the brains of the operation. The printer gets all the glory, but at the end of the day, the printer's only as good as the material that's going to it. So having Gary, constantly monitoring the water temperature, the environmental conditions, the print speed, and in fact, Gary is the brains of the operation, really telling the printer what to do and can anticipate what's going to happen before it even gets there. So these are some of the reasons why that quality of wall is so high. So here's Frank in action. You can see him on his continuous tracks driving around. And here we're seeing things like cutting some very tight corners here. The spatula helps us to do that. I know that some people are a fan of the curved walls. Some people just want something that looks exactly like everything they've seen before. You can do really both with the printer. And yeah, of course, the consistency of the walls is something that really stands out in the industry there. Let's see what we have here. Yes, Anna touched on gantry printers briefly earlier. 3D printing right now and for the foreseeable future, it's a really hot technology in the construction industry. And there are other companies that are in the space, but the vast majority of them, like some of the ones earlier mentioned in the question, these are mostly gantry printers. Again, massive machines, very expensive to transport compared to a more mobile technology. That setup time for gantry printers, not only is it kind of dangerous, you're using cranes, you're kind of climbing up on large truss systems to try to bolt everything together. But you're also working with a pretty large crew in that process, not only while you're building the printer, but while you're operating the printer. Oftentimes, you'll see a lot of larger crews out there helping to support those systems. Part of the reason isn't really have much to do with the printer as much as it does the mixing machine and the ability for these systems to really work in harmony to deliver that building at the end of the day. And of course, scale here. When it comes to whether you're looking to print an affordable home or an affordable complex or even something on the more luxury side, being able to scale and take advantage of some of those unit economics, it's something that we're able to do virtually on an infinite basis. The main restriction to the size of the building you can print with our printer is really the land that you're printing on. When it comes to the gantry printers, you're really needing to build inside of that box. So the bigger the home, the bigger the printer. So those are really the main high level things. If you'd like to learn more on that, Appius Core University will really get into some of the costs and how to judge them between, when assessing a printer. So printing in multiple sections, this is how we're able to build these massive buildings. And one thing you'll notice is this control joint that's formed between the two print sections. Typically, when you're doing traditional concrete construction, you have to get a big cement saw out to cut in these building joints, their movement joints, things like seismic joints, expansion joints. These are required by building code. So instead of bringing a big cement saw and holding this above your head, we're able to really automate that process. And there's a lot of other things we can do during the actual print by printing in sections. So after the printer's left section 1 and moved on to section 2, we're already installing outlets, getting reinforcement installed, windows, plumbing, rough-in installations for a number of systems while the printer is still operating. This is something that isn't typically done with masonry construction, but these concurrent activities can really help speed up that construction process. And lastly, operating multiple printers at the same time. This is something that we're already able to do. And if you look in the top left, you can kind of see what that looks like. Since the G code, the printer's language, it's kind of broken up into those sections, we can already deploy multiple printers, either on different projects or on the same project at the same time. This just really lends to the scalability there. If you're a construction company, you wanted to purchase one printer up front, you could very easily scale your operations and continue to grow. So one of the big questions we get is around permitting. And really our whole approach to the walls that we print has been, why reinvent the wall when you can just copy this gold standard of concrete masonry unit or concrete block construction? And we really take that to heart. So when you look at kind of over here on the left, we have two walls. On the left, it's a standard concrete block wall. And on the right, it's a 3D printed wall. You'll notice that there's a lot of things very identical about these. Things like using the exact same rebar reinforcement and at the exact same spacing, or using ladder wire and doing that at the exact same interval, or things like a bond beam up at the top of the wall. Of course, we're doing all the exact same things because we didn't want to create a whole new set of building code that we need to wait for people to adopt and wait for tradespeople to learn. Instead, we're really just copying what's already out there so we can penetrate the market much more quickly. On the right side of the screen here, you'll notice kind of a detail that you'd see, a sectional that you'd see in a set of construction documents. If you ever seen a sectional for concrete block construction, then you'll immediately know that this looks identical. The only difference is essentially you'll see kind of a squiggly line over here on the right and a little arrow that says extruded concrete wall. This is great because if you have a set of construction documents for a track home or a concrete block home, you're able to really quickly convert those into documents for a 3D printed home. So the whole process isn't disrupted here. The architects, the engineers, the building officials, the builders, the tradespeople, everybody's really doing the same thing they were doing before, just more efficiently and faster. This is really one of the big reasons why we were able to create the first commercially permitted 3D printed building in America. So, how do you design these things? Most architects use softwares like AutoCAD and Revit. So we've created plugins for those softwares where you're able to very quickly generate that tool path and create G-code. For those who aren't familiar, the printer, Frank, he doesn't speak English. He speaks G-code. That's the kind of the printer's native language. It's those instructions. And we do have some videos even available on YouTube to show you how quick and easy this is. And we're also developing some online courses to help make it even easier. Once we create that G-code, we always test it out in a simulator real quick. That way, there's no surprises when you get out to the construction site. When it comes to the questions that we receive, we have more questions on secondary construction than anything else. How are you doing reinforcement or insulation or all these other things, windows, doors, mechanical, electrical, plumbing? Thankfully, the answer is the same to every one of these questions, and that's that we copy concrete block construction. So you'll reinforce these walls in the exact same way. Slab connection details, insulation, all of these things are done identically. In fact, you can kind of see in the bottom right here that if you take a concrete block and you set it right on top of one of our 3D printed walls, all of the the infill, those kind of webbings, everything connects up perfectly. Everything looks very similar. This helps to really simplify the process and integrate this into your existing workflow as a construction company much more easily. It also helps from a perspective of someone who isn't in construction, maybe a home builder, and get delivered a little bit more quickly, and obviously you really see a very simple process. It's easy to maintain after the fact. Here's a little nod to OpusCore University. Again, feel free to check it out on our website. So I'll kind of close up here with an update on our model house that Anna had touched on earlier. So it's going to be a really exciting project. First off, it's going to be the first 3D printed home in Florida's Space Coast, a place that is, constantly innovating, and we're happy to be able to be the first here in this area. Now, don't quote me on this, but now that I think about it, I think it might be one of the first 3D printed homes, if not the first 3D printed home in a high velocity wind zone. So we are going to be building this right through hurricane season. So we're going to be demonstrating some of those capabilities when working in an environment that is pretty harsh. I know there's been a lot of interest from people involved with disaster relief and off-grid construction. And a technology like this really could be deployed in an area like that. Not only do we have battery power on the bulk truck, but being able to operate it with very limited resources is something that's really important to things like off-grid construction and disaster relief. So we'll be demonstrating how some of that can be done on this project, even if you don't really have access to power or water on the construction site. When it comes to permitting, thankfully, building officials were very, open and actually excited about this project. It's something that is familiar to them and that they understand all the documents, but kind of different, new, and exciting in the way that it is 3D printed. We really didn't have any comments on the structural aspects of the home, but when it comes to the septic that Anna mentioned earlier, after we'd submitted our septic permit, Florida released the House Bill 1379, which essentially banned septic systems in a very good chunk, over 50% of the state, a very large chunk of our land area, including where this home is. So we had to kind of adapt and created a new ATU, an aerobic treatment unit system, and kind of resubmit that. So we've been just kind of waiting for them to get that back to us, but we look like it looks like we're going to start printing here just after we're finished up with the product presentations that are going on throughout this month. So kind of stay tuned and you can see what some of that's going to be like. I have kind of a short video here showing that we'll be using a very conventional monolithic slab system. We'll be getting the printer out there on that slab, and we'll be doing this in 5 different positions, but you can kind of see what that looks like here. We'll have those. The 5th position really is helping us with a cool feature wall we'll be doing on the inside of the home. But electrical is going to be added. We'll have some window bucks that are required by code here. We'll have insulation in those cavities, reinforcement. We'll have the grout in those wall cavities. If you hide the print material, this is kind of what's inside of the walls. But we'll do the code required top plate, a very limited framing out there, and of course our roof system. We'll get our trusses formed up, our subfascia, our deck. All this stuff is very standard with construction. And then, of course, we'll be kind of trimming and finishing the home out on the inside there. So we'll be keeping everybody updated as to the process that we've been going through there. Keep an eye on our social medias and on our website, and we'll definitely be excited to share some of this with you guys coming here shortly. So that's it for my presentation here. I'll go ahead and stop sharing my screen, and I believe there's probably some questions that are going to be coming in that we can start answering for you. Thanks so much.
Is that okay?
I'm muted. Yeah, I was saying thank you, Trevor. That was very, very, very informative. So yeah, we can start picking up the questions. I can start with the who's your closest competitor. I would say right now it's really the competition in terms of technology. And the landscape today of the industry is basically gantry printers, robotic arms, some other weird equipment like a crawlers or something like this, basically existing equipment that you use to lift people up when they paint in the buildings. So yeah, people just decided to take those type of equipment and install hose on them. And in addition, also there is Episcore VR. We did not take the existing equipment and put the hose on it. We really developed and designed the equipment specifically for this task to 3D print houses. And that's really something that makes us really ahead of the game technology-wise. Because the 3D printer itself, again, this is the most agile, more quicker and easy to use equipment, very precise as well. Gary itself, in addition to that, as I said, it's the additional piece of art and really engineered, highly engineered equipment that makes the process way better and very scalable and very easy to operate by anyone. So we really, I'm proud really to say this, that technology-wise, we're really ahead of the game. And technology-wise means it's not just the equipment that works perfectly, it also how scalable this technology can be for home builders. Because what we hear from the home builders, they say, gantry printers, for example, doesn't make sense for us because it's too expensive to get in and get out this big machine, right? The robotic arms, for example, there are the companies that also use this solution. Robotic arms, they need to be strongly attached to the concrete floor, otherwise they will overlap. They have way smaller printing area, so you need to move them way faster, more time, and each relocation takes a lot of time because again you need to bolt them to the concrete slab. The robotic arms actually were not invented for the outdoor use, and none of the competitors actually have Gary or another proprietary mixing system. So what we see right now technology wise, again, that's like a 100%, 1000% confidence that we're really ahead of time, ahead of the game and time as well. But when we if we think about the operational, I would say we are just coming to that phase, because competition is not only technology, right? It's also how quickly you can produce a lot of printers, how quickly you can deploy them, and how quickly more users can actually start using this. So we right now transition into that phase, and it's really, really exciting for us as well. So I think that maybe in a year, maybe in next year, we can say like who is actually our competitor, right? Because it has to be apples to apples. Okay, technology wise, we already did a great job, brilliant job. It's the solution that users really love and want to use, but how quickly we can scale this and how successful we're going to be in that. Of course, like we're sure that we're going to achieve this 400 printers in operation, but I think that no company today in that stage, even that company in Texas who print a lot of houses, they even didn't achieve the really scalable mass scale of operations, I would say. So today we can tell only about the technology, and our technology is really ahead of the game. So Trevor, maybe you can address the question about the sealant from the fluids.
All right. How do you seal it from fluids? Usually do it. Oh, okay. Yeah. So great question. So good thing about concrete is it's inherently resistant to moisture. You know, when you're looking at large bridges or, structures, retaining walls that are designed to be in water all of the time, you're generally looking at concrete material. So we do generally put a sealant onto the walls, most often in the form of paint. This is something that in especially colder climates where there's a lot of freeze thaw, lends an extra protective layer. Now, I will say that our material is like a higher density than what you'll see with general concrete blocks. Concrete blocks, if you took a solo cup of water and poured it on there, you'll see that water, penetrate into the block and go through. Our material is kind of a more closed cell formula where we don't have very much water penetration even without that sealant. But we still do recommend, putting a coat of paint on the home, and it's something that most people really want to do anyway. There are other sealants that you can use, but generally that's a pretty affordable thing to do, and something that is very similar to what you'd see done, not just anywhere in the US, but anywhere around the world for a concrete block home.
Thank you. So the another question is the primary role to sell the equipment or to build the homes? I can take it. So I would say that the ultimate goal that we want to achieve is to really sell and rent out the printers. We basically want to be the technology provider. We want to build thousands of printers and deploy them around the world. So we really position ourselves as a construction technology company that creates best products for the home builders that then they can use and increase productivity, build more homes. Basically, we want to empower them with the better tool so they can, take the role of battling the affordable housing. We just the instrument for them. However, we see that we probably going to build homes as well, but in the beginning as a market penetration strategy, because we are the pioneers and, we need to demonstrate that the equipment works in hands of home builders. And we also want to build more showcases to demonstrate how quickly it can be. So in the beginning, we consider that we're going to do both, but ultimately, we really want to create the best technology and the equipment for the home builders. So the really believes in the equipment. So it actually may be quite like a confusion in our business model. We're saying that we want to rent out the printers and sell the material, but today we actually sell the printers. And we do this as a market penetration strategy, again, to sell printers. Probably it's going to be really like for this 1 year when we're actually going to sell the printers, we want to transition to the renting business model. So selling the printers just for cash, it's not where the business is. We really want to deploy the hardware the same as the razor and blades business model. Trevor, maybe you can tell us, how does the machine level itself on the site? We just recently actually tested the new system.
Yeah, really great question. So, of course, we want to make sure that the walls that we're printing are good and plumb and level. So, there are 4 leveling feet that are at the bottom of what we call the transportation assembly. Basically, Frank has 4 feet at his base, and there's basically a device in there that allows him to know when he's level. So he will, once in position, will kind of raise up on these 4 points, and they will get him level. This is something that is very useful out on site to essentially drive him out with an iPad, press a button to level him, go ahead and, we'll do a dry run generally and start printing. It's very quick. It takes maybe 15 to 30 minutes to reposition the printer and begin printing. Also, the walls we're able to very quickly, just with 2 points, we have a kind of a laser attachment on the bottom of the extruder. This allows us to kind of lock on to 2 points that are on the foundation, the slab, and accurately position the building very quickly, or the wall section we're about to print. So yeah, these are things that through multiple iterations and years of development we've come to make here very user friendly. But yeah, the leveling system definitely is a huge bonus out there.
Oh, sorry, I'm just typing. Yep. So the another question is, so I can start this, and then Trevor, you can add something to my answer. For an average size home, how much less lumber is required overall for an EpiScore home versus a conventional home? You still need lumber for the roof structure. Yes, that's correct. We still need lumber for the roofing system and even for the windows frameworks, for example, as of now. But for the walls, if we compare to the wood framed house, we don't need lumber at all, because all of the walls are 3D printed, and we do not install drywall to install the insulation, because we inject insulation into the walls, into the cavities. So if we really compare the 3D printed house to the wood stick house, it way less lumber. Basically for walls, it's 0 lumber. We still may use lumber for the interior walls, some of the interior walls, like in the bathrooms, for example, if it's like a shared wall, so just easier to install all the plumbing. But yeah, answering the question, for the walls, we don't need lumber at all. And Trevor, if I missed something, feel free to add.
Yeah, no, I mean, it was a really great answer there. I know that at least for projects like the model home that we're doing here, it's more of a demonstration of a more affordable home. It's essentially a 4-bedroom, 4-bathroom home. So we don't choose to 3D print necessarily just because it's cool or it's fun to do. It's really because we're able to build a stronger, better structure faster and more affordably. And if there is a particular wall inside of a home, let's say you have 2 bathrooms that are back to back, it's a very tight space, we may choose to go, we could 3D print this, but because it's an interior wall, we'll go ahead and frame it out. It'll make it a little bit easier for the plumbers to access. And the best thing about 3D printed walls and concrete is that it's durable. It is going to be there for a very long time. And the worst thing about it is that it's durable and it's going to be there for a very long time. And, we don't know what trends are going to be around 50, 100 years from now when the home's there. But we do know that bathrooms and kitchens are remodeled more than any other room in the house. So it does make sense in some case, just because we know that users in the future will likely have different tastes and preferences than what we do now. It does make sense sometimes to have wood framed walls in the interior. And interior walls with wood framing are very different than exterior walls. On an exterior wall with a wood frame, you don't just have your framing crew come out. You're also getting, a vapor barrier up there. You need an air gap in there. You need to get a siding on there. You're worried about water penetration behind. You have not only insulation, electrical, plumbing, all those other finishings. You have something like 14 different materials and 4 different trades that are coming in to finish those exterior walls for a wood framed home. We can just use essentially three materials, the print material, the rebar, and the insulation, to be able to make the walls themselves. And we're the only ones doing it, or the contractor is the one doing it. So it really simplifies things when you're able to eliminate all these scheduling hassles and everything that you need to do. On the interior walls, though, you aren't worried about water infiltration. You're really just doing studs and drywall. So although drywall can be a big pain, it's something that if you're only doing it in a very limited area, there are some cases where you can do it. And in those cases, go ahead and use wood framed wall. But in the vast majority of situations, 3D printed walls are going to do you pretty well. I know there are, besides walls, roofing systems. There are a number of roofing systems that do not involve wood. I know that we used a concrete floor system in the Dubai building, especially in the commercial realm. And in places outside of the US, you do see a lot of concrete structures that do include kind of cast in place concrete floor systems. Since we're following concrete block building code, you don't make roofs out of concrete blocks, but there could be a point in the future where there are roof systems that are we've seen a lot of modular roof systems starting to catch on, and it could be that in the future there are even printed components or outright printed roof systems. But as of right now, that's not something that we've tested. It's not something that we advertise. But as more people use this technology, it's amazing what you'll see people able to accomplish with it. What kind of ideas you can bring to life when you have really design freedom to do anything. So I'm excited to see what some of those developments are in the future.
Yeah, me too. So the question is, I'm in the Central Florida area working for local natural gas company. There are multiple home subdivisions in progress now. Have you reached out to these builders? And if so, how interested are they in your technology? So our customers and early adopters and people who come into the product presentation to purchase printers, they reached out to these companies, and they even have already in talks with them, not in the specifically in the natural gas company, but like for the subdivisions. So we have access to this market and like a type of contracts through our first buyers of the equipment. And also, as I mentioned, we in a very good and promising conversation with the national home builder, one of the national home builders. So they interested tremendously. They saw all of the other technologies, and they literally said what Episcore has is the best that we've seen so far. So we really have a lot of hope for this ongoing conversation, and let's see how it goes. Next question, what does the temperature have to be able to use the printer? Summer versus winter, and what is the curing time of the product? I assume it's the 3D print material. After the product has cured, can additional wiring and plumbing be added? If so, what would use to cut the product with? So I can start and you can complete. So the temperature, basically, we have the industrial grade of all of the parts on the printer and on Frank and Gehry. So of course it's, for example, in Dubai, the printer were used mainly during the night, but even during the night, it was like a 35 Celsius. It was very hot. And during the day, the printer was just left on the construction site under direct sun exposure. So it can be used within the extreme temperature conditions. The hardware itself is not going to be damaged. It's just for people very challenging to operate in like a 50 Celsius during the day. About the 3D print material, 3D print material can cure quicker during the hot weather conditions, but we have some like the safe space in terms of the curing time for the material, so it's not that fast. It's not going to stuck in the hoses, for example. And typically the 3D print material really become a rock, like it does not move and it's not soft anymore within the like a full curing. It's like a 1.5 hour. But what is more important, in 15 minutes, the material lose the entire mobility. So it's more like the technical stuff for the 3D printing process. But after 15 minutes, basically, material doesn't move, and that's something that allows material and layers to be stacked on each other. And we don't need to take a pause just to wait for the previous materials to, you know, get set and dry to continue printing. We can print without any stops. What was the actual question? Additional wiring and plumbing. Yeah, so we can actually do that, and it's because the material within the like some period of time after printing it's still soft. It's very easy to cut, and it's actually something that we did in Texas. So we can do some wiring and drill in some holes just maybe like a 30-40 minutes after the printing. Better do this like after an hour or something like this. But Trevor, maybe you want to add something.
Yeah, definitely. I guess on the temperature side first, yeah, absolutely. I mean, there's a variety of different environmental conditions across just the country, let alone around the world. That small tiny home, I mean, it was absolutely snowing out. The yellow tiny home you saw, and of course, Dubai is a desert. So we do have experience printing in a variety of climate conditions. Most companies that sell concrete-like materials, there's generally at the very least kind of a hot weather and colder weather mixes. We do know that depending on how that temperature is, there are different mix designs for very, very cold weather seasons versus very hot weather seasons. Now, with that being said, they're all things that you can overcome, generally speaking. I mean, Antarctica, we've not tried out there just yet, but generally speaking, if you're able to build a concrete block home out in the weather, be it the rain, the sun, the cold, then you can 3D print a home out in that weather. Yeah, and when it comes to adding things like, electrical outlets, plumbing in the walls, reinforcement, this is something that is especially easy to do 2 to 12 hours after the print, after the layers have been extruded. Generally, we'll take like an oscillating multi-tool with a grout blade, and we can very easily buzz in the outlet holes and rough in our outlet boxes. Now, let's say you get to it the next day or even a few days or even a week later, anytime after. You're able to still essentially do the same thing, but we'll generally use like an angle grinder or something a little more substantial just because it goes faster, but you could still use an oscillating multi-tool to cut out those outlet holes. We're big on counting minutes and seconds as we're doing our operations, so we're always going to try to do it the most efficient way that you can, but we also train operators to make sure that they're able to do, retrofit work or work after the fact. And since it is really identical to concrete block walls, you're able to do those kinds of things after the fact, just like you would with a concrete block wall.
Awesome. There was a question about if maintenance is going to be part of the contract. Yes, it is. So it's going to be part of the renting contract. When we rent out the printers, it's basically going to be a part of our work to do the maintenance, repairing if something happens, for example. But also when company is going to rent out the printer, they also will need to complete a simple training course. We just want to make sure that people who are going to use it, although it's very easy to use, that they at least know how to use simple, the screwdriver or something like this. So we want to make sure that people know the basic procedures how to use the printer. And about the maintenance, so what is really great thing about the product that we created, it's very easy to get it for the maintenance. For example, we have the polyurethane, or it's basically rubber slots into the mixing chamber where the material mixed with water. We also have this polyurethane, or a rubber cover inside the extruder and all of the parts that are in constant contact with the concrete. That means that if you had just the steel, for example, like a standard steel material, the concrete will, when it's dry, it just stuck to it. and you will spend hours to clean it, and you will even need to use chemicals to, you know, remove the parts of the concrete because it's going to be already like a fully hardened. So to avoid this situation, we just designed and incorporated this rubber slots. So for example, when you see that, oh, okay, this slot is already so exhausted, you just take it off very easily and install the new slot. And we actually also going to sell this slots and like all of the other parts that needs to be constantly replaced. So in addition to renting and material, we're also going to have the revenue coming from all of the training courses, education, and all of the consumables that we going to sell. So this is basically about the maintenance. So we don't expect that it's going to be so hard and expensive for us to do the maintenance.
Yeah, no, I mean, that's a really great point there, especially when you kind of factor in that the entire system is being monitored internally and remotely. So we can diagnose and troubleshoot a printer without ever going out to the site. Just like when your car check engine light comes on, well, we have very similar systems to monitor the printer and mixer, so you can catch problems before they end up really having any effect on your operations. Consumables are definitely a thing, but not very significant. Things like sponge cleaning balls, priming fluid, cavity pumps, affordable parts that have really long duty cycles. But yeah, we've spent a lot of time to over the last version compared to the version we have now of the printer on modularity, making sure that almost every component that goes into the printer and mixer can be removed, replaced, and upgraded modularly. We know that if our customers aren't using the printer and using print material, then neither of us are making money. So we knew that we'd need to make sure that not only could we catch potential issues before they'd happen, but also if there is a non-software solution, a hardware solution that needs to be deployed, that we're able to very easily ship something over, pull a bolt out, and replace whatever part it might be. So yeah, maintenance is one of those things that we put a lot of time into making sure that we can streamline.
Yeah, maintenance and manufacturability of the printers as
Yes.
well, because our goal is to rapidly manufacture a lot of units. So in addition to create really great product, it has to be very easy to manufacture. Otherwise, we will die when we go to expand our manufacturing capabilities. So yeah, that's really very sophisticatedly engineered robotics and equipment that we're really, really proud of, and really happy to start deploying this on the market. And I think we come into the last question. It's Trevor about the footer. And
Yes, yeah,
from Anthony.
yeah, assuming actual, yeah, it says, I'm assuming the actual footer needs to be completed prior to bringing in the equipment. Is it possible or feasible to use this for the foundation itself? What if I want an actual wood floor system versus a slab? Can this be used for the walls in this condition? Yeah, I mean, all really great questions there. So first things first with this, I mentioned this earlier that we use the system not because it's kind of fun or cool, but because it's better, faster, and more affordable. So with concrete slabs, the current method of pouring concrete slabs generally involves, a very large diameter, 3 or 4 inch diameter pipe, pumping it in at, high speeds into a formwork. And the material being used is kind of meant to flow very easily, kind of like a puddle. We don't print using that type of concrete. They don't pour using our type of concrete. So although it may technically be possible to print an entire foundation, it's kind of like painting a wall with a Sharpie marker. It's possible, but it would probably take a lot more time and be more frustrating. Now, there could very well be a possibility of things like formwork, which typically you make with wood and then you remove when you're done, when you're making a concrete slab. There could be a case to be made for doing formwork. It's not something that we've done just yet, but it does make a lot of sense in theory. And I don't really see why it couldn't be done. It's just something that we'd not done ourselves in the past. So yeah, there is definitely a potential use there for the printer in something like in formwork or in slab construction. When it comes to a wood floor system versus a slab, in most places, wood tends to deteriorate when it comes into contact with ground. Even pressure treated lumber, it rots very quickly. So if a home is only as strong as the foundation that it's built on. So we do recommend, as a manufacturer, to build on a concrete foundation, most preferably a monolithic slab, although it could be possible to print on something like a stem wall. So yeah, I mean, I'm not going to say that a wood floor system isn't possible. But especially if you're doing a crawl space or something like that, you would probably engineer it more like you were building a second story floor system. So you could achieve that crawl space, tying off the inside of the walls. So it'd be more like a stem wall foundation tied into with that floor system. But in the world of construction, if it's possible with concrete blocks, it's possible to do with the printer. That's generally the situation that you're looking at. So yeah, I mean, if what you have in your mind there, I'm hoping I'm describing the question correctly. But yeah, if you could add this sort of wood floor system you're describing in a concrete block home, you could absolutely do it with a 3D printed home.
Okay, so I think that we done. Actually.
All right.
Yeah, it was
Well, I guess.
almost 2 hours.
Yeah, it's
1.5 hours.
thanks so much for sticking around, everybody. Yeah, it's been great to have everybody here today. I'm glad we were able to answer some of your questions. I hope you're able to get some new material on here. Again, if you missed something, we're going to have this recording available to those that had registered for this, both those that were here and others who were really just waiting on the recording for after. Feel free to reach out to us. I know we have Milton Kobus. He works with us in sales. I'm sure some of you guys have been able to contact him in the past. But if you are interested in purchasing printers, leasing printers, or coming to our product presentations, I definitely recommend reaching out to Milton. And I'm sure the information for his contact is provided. We can also send that to you along with the recording the video. So thanks so much. I think we've talked enough here for today. And if you have any closing words, that's it for me. Thanks so much, everybody.
Yeah, thank you very much for joining us today. Thank you, Trevor. And yeah, we will send the email with the recording, some of the information about the link for the Start Engine, and also the contact information of Milton, if somebody would like to connect with him. Milton Kobus is our Director of Sales. By the way, we didn't introduce him in the beginning, but yeah, this is our team, and we were really happy to see you today. And go to Start Engine, invest in us. Thank you very much. Have a great day. Take care.
Thanks, everybody.